So today we solve a top 10 numerical on alternating current. Okay, class 12 physics. So first numerical, RMS and average value. For solving a numerical, first step is read the question very carefully. Okay, and here the question is that an alternating EMF is given by E equal to 325 sine 100 pi t volts. That equation is very important here. Okay, for solving these equations very important. Now find the RMS value of EMF. Okay, and you see that this expression almost look like a EMF, that is EMF maximum sine omega t, and that's the EMF maximum that is equal to 325. So RMS EMF of RMS that is equal to maximum EMF by root 2. So means almost if I 325 divided by root 2, solving with the help of calculator, and you get approximately 229.81 volt. Now second question, so find the frequency. Find the frequency. So here is omega, and you see the omega that is equal to 100 pi. So the frequency means omega that is equal to 100 pi. If we compare these two expressions, so you know that omega equal to 2 pi f. So 100 pi, so pi with a cancel. So frequency equal to 100 by 2 means 50 hertz. That is the second answer. Third answer, find the average value over half cycle. Okay, average value of half cycle. So half cycle means very important. So number C, half cycle. So that is the EMF of half, that is equal to 2 by pi times EMF maximum. So that means you get a 2 by pi means 3.14 and maximum means 325. You solve this and you get a approximate value is 207 volt. Okay, that's the third answer. And these are the formula for half. Okay, average value of half cycle. Okay, that's the first numerical. Second numerical, power in AC circuit. So here 60 watt. Here power is given 220 volt connected across the 220 volt AC supply. Find the resistance of the lamp and the RMS current drawn. That's very important here. So see that number 2 question number 2 here. Actually there is a lack of space here, so that's why number 2 solving here. So power given actually 60 watt, RMS also given. So actually P equal to, you know that V times I, and power is given and voltage also given. So power is given, voltage given, current is not given. So this current I convert to R. V equal to IR. So IA equal to V by R. So that means V by R. So that is equal to V square by R. So P equal to V square by R equal to. So if I cross multiply here, so V square by P. So final expression R equal to V. So V square means 220 whole square by power. Power is 60 watt. So if I solve this with the help of calculator, just adjust a number here. So you get approximate value is 806.6 ohm. Okay, that's the resistance of the lamp. And what is the RMS current? Okay, now we find the current I. Okay, so here I, so you know that is a power and voltage. Okay, so what is I? So I equal to P by V. So here you get power equal to 60 watt, voltage is 220 volt. So here you get 6 by 22 means 3 by 11. That's the current. Okay, and these are the, actually this current is the RMS current. This current is the RMS current, and that value is almost, if I solve this, 0.02 or 0.27 ampere. Okay, that value is very low. Okay, that's a numerical number 2. So third numerical is very important. Resistance and impedance. A series LCR circuit R given 10 ohm, L given 0.2 Henry, C given 100 microfarad, connected 220 volt 50 hertz AC supply. Find the reactance XL and XC, impedance and current in the circuit. Okay, so XL that is equal to omega L and XC that is equal to 1 by omega C, and Z that is equal to root over of R square minus R square plus XL minus XC whole square. Okay, so that's very easy. There's a given data here for omega L. So now with the help of these XL, so here XL, so omega L, omega frequency 50 hertz, 2 pi a, that's the linear frequency. So if you given a hertz, these hertz represent linear frequency a, and rad per second. So if I given the SI unit is rad per second, so that means omega. Okay, just keep in mind. Okay, so when a unit is hertz, so means linear frequency, or when SI unit is rad per second, so that's the angular frequency omega. So the 2 pi f linear frequency. Okay, so here times L given 0.2 Henry, so 0.2, so 2 pi means 3.14, frequency is given 50 hertz times 0.2, and solve this, so you get 62.8 ohm. Okay, there's a inductive reactance XL. So what is the capacitive reactance? So capacitive reactance means XC that is equal to 1 over omega C, means 2 pi, pi means 3 point given data 2 into 3.14 times 2 pi a, frequency 50 hertz, and now that C capacity is 100 microfarad. So 100 means 100 into micro 10 to the power 6. So micro here, so going to up numerator, so minus turn into plus. Okay, solving these and you get a result. So actually put the data in that equation and you get XC. So suppose the XC value that is 31.83 ohm. That's the XC. So capacitive reactance. So what is the impedance? So you know the XL and XC, so minus these, and you know the R also 10 ohm. I put the all data here and you get a Z impedance. Well, okay, that's very easy. Okay, now the last part, current in the circuit. So there's a homework problem solving this, and actually put the data here and you check that. So data is 32.57 ohm. Okay, actually put the data and you also check that this is right or wrong, or you get. So if a Z is given, so find the I equal to, from Ohm's law, V by Z. So V given 220 volt, so Z given 32.57. So solving this you get ampere is 6.7 ampere current. That's a C answer. Now question number 4. Question number 4 said that in the average circuit, question number 3, calculate the phase angle between the voltage and current and power factor. That's very important. How to find that phase angle between voltage and current? Okay, that's very important. How to find phase angle between voltage and current? So here the phase angle is a phi. That's mean tan inverse XL minus XC by R. That's the phase angle. Okay, so here XL and X is find actually. So you get XL is at 62.8 and X is 31.83. So tan inverse 62.8 minus 31.8 by R. So resistance is given, that is a 10 ohm. So put 10 here, and that is we get tan inverse. So solving this, so we get a 3.1, and the final result is 72.12 degree. There's a phase angle phi. So here we see that XL is greater than XC. So XL is greater than XC. So now here that is a XL greater than XC means that circuit is a totally inductive circuit, because the inductive reactance is more than capacitive reactance. So that's why that's the inductive circuit. Inductive circuit. Okay. So now the phase angle between and voltage and current. What is the power factor? So power factor, that is equal to cos phi. So power factor, you know, that is equal to cos phi. Cos phi. So cos phi means 72.12 degree, and from this we get 0.307. Okay, that's the value. That's the power factor. We cos 0 with a 1 and cos 90 with a 0. So that's why there is a decay here. Okay. So that's the solving question number 4. And now we jump to question number 5. In series LCR circuit, R is given, L also given, C also given. Okay. Find the frequency at which the circuit will be at resonance. Okay. So find the resonance frequency. That means if not. So number 5, so a resonance frequency, that is equal to 1 by 2 pi root over of LC. Okay. So we need just only 1 by 2 pi means 3.14, and root over of L. Here L is given, L is 0.5 Henry, C is 80 microfarad. 0.5 Henry and 80 microfarad, 10 to the power minus 6, and solve this, and you can get the result is approximate value 25.16 Hertz. Okay, that's the resonance frequency. Okay, and that frequency the circuit will be resonance. Now the question number 6, very easy question. For the circuit, question number 5, calculate the Q factor of the resonance. Okay, Q means quality factor. So finding quality factor, so use the formula Q, that is equal to, we get omega naught L by R, and you know that what is omega naught. So here omega naught is, that is frequency F naught. So omega naught means that is actually 2 pi F naught L by R, and 2 pi, you know that 2 pi is 3.14. Resonance frequency is resonance is 5.16 Hertz. Put here L value also given here, that is a 0.5 Henry, and R is given is 50 ohm, and we get a Q value. Okay, so that's a homework problem. We solve this and with the help of calculator, and we put the answer in comment section. I will check that. Now question number 7. In LCR circuit, RLCR given, connected in 230 volt 50 Hertz AC supply. Find the average power consumed. That's very important. How to find the power? Okay, first find that, very important, finding power. Actually formula power, that is equal to, we know that VI times cos phi. So here voltage and current. So you see that voltage is 230 volt. Okay, and current is not given here. So now find the current. Okay, and find the phi also. Okay, so how to find that is voltage is given 230 volt, not I. So from Ohm's law. Okay, so I equal to V by Z, and also Z equal to, you know that root over of R square plus XL minus XC whole square. We put the data all here, and put here, find Z, put in Z, and V also know 230 volt, find the current I, put I, V and cos phi. So how to find phi? That is tan inverse XL minus XC by R. How to find XL? XL means omega L, and these are frequencies hertz, so that's the frequency F, normal frequency, okay, not angular frequency. Now put the data in 2 pi F is here 50 hertz, okay. Actually solve this, how to find XL and XC when frequency are in hertz. So that's very easy, okay. Put the all data and cos phi, so we find phi, cos phi, and put data, we get a power value, that's times of watt. Okay, number 8. In step down transformer, convert 220 volt AC to 11 volt AC. In secondary, coil has 50 turns. Find the number of turn in primary. That's very important. And it's all here. So, question number 8. In step down transformer, okay. So, step down transformer, keep in mind, these are the step down transformer. Okay. So, here 220 volt AC to 11 volt AC. So voltage in primary, that is 220 volt AC, and voltage in secondary, that is 11 volt AC. So number of turn in primary, that is secondary, primary is fine. So given the N is 50 turns. Okay. So you know the formula is Vp by Vs, Vp by Vs, okay, Np by Ns. So Vp is given 220 volt, Vs given 11, Np find unknown here 50, so that is at 20, so you get Np equal to 50 times, these are 1000, these are the 1000 turns, okay. These are the 1000 turns here. That's the question number 8. Now the question number 9, yes, the final answer is primary turn is 1000. So in LC oscillation frequency, inductor 1 millihenry, capacitor of 1 microfarad connected in a LC circuit, find the frequency of oscillation. That's a direct question. That is F equal to 1 by 2 pi root over of LC. You put the L and C value and pi is 3.14 and put the all data here and you get frequency in hertz. Okay, and you try to solve this in your own. Okay, so number 10, current in at resonance. So coil of resistance of 20 ohm, inductance of 1 henry connected in a series of capacitor 100 microfarad, and across the 220 volt 50 hertz AC supply, find the current at resonance. Okay, current at resonance, okay, keep in mind. So current at resonance, so first find that is F naught, resonant frequency, that is actually 2 pi root over of LC. Here L is 1 henry, C is 100 microfarad, and solve this and you get 15 point, actually solve this, okay, and you do it 15.91 hertz, actually solve with the help of calculator, that's why you solve it very fast. So at resonance, keep in mind, at resonance, okay, current series of AC supply, current at resonance, so means XL, that is equal to XC, that's the condition for resonance. Okay, and when at XL equal to XC, so Z equal to R here, so that's fourth term is 0 and R square, these two are cancelled, we get Z equal to R. So current I, that is equal to V by R or Z here. So V given, that is actually 220 volt, and that is 220 volt, and R is given here 20 ohm. So 220, that is cancel these to 11. So that is 11 ampere. That's the final answer. Okay, that's the current at resonance. Current at resonance. That's the very basic numerical or top 10 numerical, very important for board exam. And you solve this with the help of calculator. Actually in CBSE board, calculator is not given, but actually the number, actually there is a calculation is very easy. Okay, I do not give that, that is a complicated number here. So when you solving this. These are very simple number, and do not solving very typical calculation check here. Okay, just keep that part. Or if you have some facing the very typical complicated calculation, actually say that please keep that. Okay, so you have lost a 0.5 or 0.1 marks. Okay, if you put the use the formula correctly and you do 2 or 3 step solving very good. And now for time consuming method, you have to skip that part. So you get if exam maths is 3 marks, so you get a 2.5. That is enough. Maximum 2.5. Or sometimes also you give the teacher the examiner think that you do it hard and you get lack of time. So sometimes you put a teacher give it 3 out of 3. Okay. So solving this numerical very important with the help of NCERT book, and you also the any other book HC Verma or various book in market here. So you solve that numerical. If you solve the numerical, the profit is that the concept clearance is very perfect, and the concept remember very long time. Okay, so today end of class here. Thank you.